Welcome back to ET Media. Good afternoon. This is Will Henry again with One Solution Group. I've got with me today Jordan Mayberry, one of our Extru-Tech technicians. He'll be assisting. So today we want to focus a little bit on our energy management valve, or EMV. So as you look, the first thing you'll notice is the real estate. It's a pretty small unit, and this is for a 525 extruder, but still the sizes are comparable as you go up to the 750 and 925. So some of the key design components that we kept in mind as we designed this is, of course, real estate. We've got a lot of clients that are running traditional methods of die management and capacity rates. So we wanted a solution that would allow them to install the EMV without a whole lot of rework on their die setup, on their hoods and pneumatic systems. So notice, first of all, the depth that we have on this. What allowed us to do that, number one, is integrating the reject portion into the final head. And that allowed us to keep our adjustments when we install the EMV to around a 2-inch extension of the die plate. And in most cases, that can be installed with minimal rework on the pneumatic system. It's a very key feature. So right now, as you look at this dial here, as we start up in reject mode, that allows all of our undercooked, underprocessed product to go down into a reject tote instead of coming out the die and contaminating the die and the hood and the knife with that raw uncooked product. So in terms of food safety. Now in reject mode, another feature that we like to see is we're not just 100% open on reject. So Jordan, if you wouldn't mind, go to 50% on reject. This allows us to start putting energy in the product while we're still in reject mode. And when we start getting our barrel fill, it acquires our back pressure much quicker and allows us much quicker acquisition on our CCP temperatures. Once we've hit our temperatures, we then go to process. Now our system here is hard coated at 185 degrees Fahrenheit, and it's an automatic step to go forward. Obviously those can be set to whatever criteria that you need for your food safety system. So now that we're in process, now we've got our feed coming out of the EMV. Another critical design component for us to maintain even die flow is we've got 8 openings there, and they're all closing at the same proportion. So right now we're at 50% open. If we go down to say 25% open, so again, that helps us maintain nice, even die flow. We're not trying to restrict one main flow of product. We divided that out equally to all 8 of those openings. It's also important to note for this what we're looking at here, this plate right here is a flare out, which is typically an add-on. So when we discussed the extensions of your die, because of the EMV, we have to negate this piece here, because we flare this out so we can use that 10-hole insert die that we explained earlier. So another critical feature that the EMV provides us is not only from the food safety standpoint, considering the reject, but also being able to finely tune and manage other aspects of the process, like cook or gelatinization of your starches, denaturing of your proteins, and getting that target correct, but also managing the appropriate back pressure you need to fill up your heads to get the cook and retention time you need, but also bulk density. So the EMV, perhaps combined with a VFD for the extruder itself, allows you much more flexibility on targeting cooks and densities, expansion ratios on a wide range of products. And that's all without changing the internal components on the screws themselves. So with that, that concludes our brief tutorial on the EMV. Thanks and have a great day.